So for today's class, class 69, we were identifying the relationship between frequency, wavelength, and wave speed. So just to use some numbers we've used before, um, in class we were calculating what the wave speed was, and we were calculating the wavelength and the frequency pretty accurately. So just to kind of go through this, I'll just throw down some numbers. We had 6 meters for the wavelength there, this was 3, this was 2, and this was 1.5 meters. Our frequency for this first one here was about 2 hertz. This one was 4 hertz, this one was 6 hertz, and this one was 8 hertz. Each time multiplying to the exact same number. In this case, 12, which was actually also our velocity. So we come up with a relationship that velocity equals frequency times wavelength. So how does this happen? How do the units compare here? Well, if you notice, wavelength has units of meters, frequency has units of 1 over seconds. So meters times 1 over seconds equals meters per second. So we simply have to multiply the 2 there. How do the values of frequency and wavelength compare? Frequency times wavelength equals velocity. And just writing down our equation again one last time, v equals f lambda. This is how it shows up on your equation sheet. So again, v is velocity in meters per second. F is frequency in hertz. Remember, hertz is equal to 1 over seconds as well. And lambda is wavelength. And that has to be in meters. So now we're just going through some practice questions. The first one says a wave traveling through a medium has an amplitude of 0.2 meters, a wavelength of 0.4 meters, and a frequency of 10 hertz. Calculate the speed of the wave. Now actually the amplitude is unneeded information, so you don't need that 0.2 meters. We'll just write down the wavelength then. That's 0.4 meters, and the frequency is 10 hertz. So v equals f lambda. V equals 10 hertz times 0.4 meters, which comes out to be 4 meters per second. Now in class, most people got this one wrong, or at least didn't get full credit, because they did not show all work, including equation and substitution with units. So please don't forget to do that. The next question says, a G on a guitar has a frequency of 196 hertz and a wavelength of 1.24 meters. So we'll write those two things down. Frequency is 196 hertz, and wavelength is 1.24 meters. So again, using v equals f lambda, we have 196 hertz times 1.24 meters. And that comes out to be 243 meters per second. And that's our velocity. Now the last one here says, it is important to note that wave speed will not change as long as the guitar strings properties do not change. With that in mind, what would be the wavelength of a C note with a frequency of 256 hertz? I should have mentioned that it would be on the exact same string. So we know the velocity then is 243 meters per second. The frequency is 256 hertz. So using v equals f lambda, v is 243, f is 256, and lambdas are unknown. To get lambda alone, we have to divide both sides by 256, so 243 divided by 256. We get 0.95 meters is our wavelength. So the question is, does this make sense and why? And it does make sense, yes, because we just noticed when the frequency went up, the wavelength went down. What do I mean by that? Notice how for the first one, the frequency was 196 and the wavelength was 1.24. In the second one, the frequency was 256, so the frequency got bigger by 60. Therefore, the wavelength has to get smaller. So it has to be smaller than 1.24 meters, and it was 0.95 meters.